In this video, we are going to solve problems for resistances connected in series. Let's start with question 42. The question says, three 22 ohm resistors are connected in series across a 125-volt generator. What is the equivalent resistance of the circuit? What is the current in the circuit? So we have three resistances here. I will call them R1, R2, and R3. And each of these three resistances have 22 ohms. 22 ohms. I need to find what is the equivalent resistance. Equivalent resistance for a series circuit is given by adding the individual resistance. It will be R1 plus R2 plus R3. And when you add the individual resistance, you get 22 plus 22 plus 22, which will give me the answer as 66 ohms. This is the equivalent resistance. Next, they want me to find what is the current. So current in the circuit is given by the potential difference across the generator divided by the equivalent resistance. Potential difference is 125 volt and the equivalent resistance we calculated is 66 ohms. And when you solve this, you get the current in the circuit as 1.89 ampere, which you can round off to 1.9 ampere. Question 43. The question says a 12 ohm, a 15 ohm, and a 5 ohm resistor are connected in series circuit with a 75-volt battery. What is the equivalent resistance of the circuit? What is the current in the circuit? So we solve this in a similar manner as we solved the previous problem. I will write R1 equals 12 ohm, R2 equals 15 ohm, R3 equals 5 ohm, and my battery voltage is 75. I will calculate the equivalent resistance by taking sum of all the individual resistances. So R equivalent will be R1 plus R2 plus R3, which will be 12 plus 15 plus 5, and that will give me the equivalent resistance as 32 ohms. The next part is to calculate the current in the circuit. Current I is the potential difference across the battery divided by the equivalent resistance. Potential difference here is 75 volt. My equivalent resistance is 32 ohm. And when we solve this, you get your current as 2.3 ampere. Question 44. A string of light has 10 identical bulbs with equal resistances connected in series. When the string of light is connected to a 117-volt outlet, the current through the bulb is 0.06 ampere. What is the resistance of each bulb? So here you have 10 resistances, and each of these, so here you have 10 So here you have 10 identical bulbs, and each of these bulbs have the same resistance. So let the resistance of one bulb be R. So the equivalent resistance for 10 bulbs will be 10 times R. They are all connected in series to a 117-volt outlet. So my battery voltage is 117 and the current through the bulb is 0.06 ampere. I need to find what is R. So we use the rule for R. We know that R equals V over I. So I'm going to write this as R equivalent. Now let's substitute. R equivalent is 10 times R equals V is 117 over I. I want to find what is the resistance R here. So we will divide by 10 on both sides. So we get R equals 117 over 0.06 into 10. And when you solve it, the answer that you get is 195 ohm. So each of the light bulb has a resistance of 195 ohm. Question 45. A 9-volt battery is in a circuit with 3 resistors connected in series. Part A of the question is asking you, if the resistance of one of the resistor increases, how will the equivalent resistance change? Now, in a series circuit, equivalent resistance is given by sum of the individual resistances. So if any one of the resistance increases, equivalent resistance will also increase. And if one of the resistance decreases, equivalent resistance will also decrease. So here in part A of the question, they said that one of the resistance increases in value. So my equivalent resistance must also increase. Part B of the question is asking you, what will happen to the current? Now current is inversely proportional to resistance. If my resistance increases, current will decrease since it is inversely proportional. So when I increase one of the resistances, my equivalent resistance increases. And since current is inversely proportional to resistance, if my equivalent resistance increases, current will decrease. Part C of the question is asking you, will there be any change in the battery voltage? There will be no change in the battery voltage because the change in the resistance value, the increase in the resistance value is compensated by a decrease in the current value. And the potential difference, the total potential difference of the battery will remain the same. There will be no change in the battery voltage. Question 46. Calculate the potential difference across 3 resistors, 12 ohm, 15 ohm, and 5 ohm, that are connected in series with a 75-volt battery. Verify that the sum of their potential difference equals the potential difference across the battery. So here we have been given 3 resistance value. I will call R1 as 12 ohm, R2 as 15 ohm, and R3 as 5 ohm. They are all connected to a 75-volt battery. So my potential difference of the battery is 75 volt. And we need to calculate potential difference across each of them. So I need to find what is V1, V2, and V3. If I want to find V1, V2, and V3, first I need to find what is my total current. And if I need the total current I need to know what is the equivalent resistance. So we will start with finding the equivalent resistance. Using that, we will find the current. And using current, we will find the individual potential differences. So let's start with equivalent resistance. Since these resistances are connected in series, I will write R equivalent as R1 plus R2 plus R3. That will give me 12 plus 15 plus 5, which is 32 ohms. After we get the equivalent resistance, we will find the total current. Current I equals V over R equivalent. So we can substitute the V as 75 divided by 32. And that will give me the value of current as 2.34 ampere. Once we find the current, we can use the value of current and the individual resistances to calculate V1, V2, and V3. V1 will be a product of current with resistance 1. The potential difference across resistance 1 will be a product of current times resistance 1. So current is 2.34 times 12. That will give me potential difference across V1 as 28.08. V2, the potential difference across resistor 2 will be I times R2. So I is 2.34 times 15. That will give me 35.1 volt. V3 will be I times R3, the potential difference across resistor 3. 2.34 times 5, which will be 11.7. So these are the potential difference across resistor R1, R2, and R3. The final part of the question is asking us, verify that the sum of the potential difference equals the potential difference across the battery. So we need to verify that if V1 plus V2 plus V3 will give us the potential difference of the battery. So let's calculate, let's add them. 28.08 plus 35.1 plus 11.7. And when I add them, I get my answer as 74.88 volts, which is almost close to the potential difference across the battery. So we verified by adding the individual potential difference across each resistor. And when we added them, we got a potential difference very close to the potential difference of the battery.